Hello guys, hope you are doing well. This is me, Mubin, your physics teacher. So we were discussing about momentum, law of conservation of momentum, collision in one dimension. Now the topic is two-dimensional collision, 2D collision, or you can say that law of conservation of momentum in two dimension. What does it mean? Suppose that a body is coming towards this body, okay? It do not collides with head on. It collides in this way, okay? This is not face to face collision. Now the body moves in this direction and the other body moves in this direction. This is the angle theta. This is the angle theta 2, okay? So this is called two-dimensional collision in which the body is moving in two dimensions. Listen up. There is no matter whether the collision is one dimension or two dimension, momentum must be conserved if there are two dimensions. If there are two dimensions, momentum must be conserved in in both dimensions. Diamensions. What does it mean? What does it mean? I am saying that the momentum of x-axis initially should be equal to the momentum of y-axis finally. Sorry, x-axis finally. Did you get it? The momentum of x-axis initially should be equal to the momentum of x-axis final, and the momentum of x-axis y-axis initially should be equal to the momentum of y-axis finally. Okay, it means that x component momentum must be conserved. It means that p in x direction in x-axis must be conserved, must be conserved, and momentum in y must be conserved in two-dimensional motion, must be conserved. Okay, let us take some examples over here, please. Now, okay, so consider this example. Here's a body, here's a ball. It strikes with a, here's a body A, here's a body B. It is moving with a velocity of 500 meter per second. Okay, and its mass is 1.6 10 to its power minus 27 kg. Its mass is 1.6 10 to its power minus 27 kg. They both strike with each other and move with some velocities like this. This angle is about 60 degree and this angle is about 30 degree. Okay, this is VA, this is VB. What are the magnitudes of VA and VB? So, coming straight to the point, the thing is this is two-dimensional collision. Okay, we know that in two-dimensional collision, Px initially is equal to P by Px finally. Okay, and Py finally and Py initially are equal. Okay, so what is the momentum in x-axis at initial stages? It was m1 v1 plus m2 v2, isn't it? It was the initial momentum at x-axis. Here m's are equal, so we will not write m2 and v2. Okay, I will write mv2. It is equal to, okay, now what is the momentum in x-axis here? m1 v1x. Okay, here are m1 and it is ma, so we will write va and vb. m1 va x plus m2 vb x. Okay, so the thing is, what is the value of m? We don't care, the masses are equal, so we can take common and cancel them as well. Mass va plus vb must be equal to vx. What is vx here? It is v cos theta, isn't it? V cos theta, and primarily v cos 60 degree. And what is the momentum here? V cos v cos 30 degree, isn't it? So we can say that m va cos 60 degree plus vb cos 30 degree. Okay, we can cancel m from m. What is the vb here? Vb is 0. Vb is 0. So we can say that 500, because Va was 500. 500 is equal to Va cos theta plus Vb cos 30. Okay, this is the first equation we are getting. What are the momentum in y-axis? What are the momentum in y-axis? So initially this collision was in x-axis, so the momentum is y was 0. So py would be 0 at initially, because these are moving in x-axis. Okay, what would be the final momentum? It would be ma v sine theta. Okay, v sine theta, vb sine theta, primarily vb sine 30, and this would be vb sine 60. So thus we can write it vb sine 30 and vb mb vb sine 30. Masses are equal, we can take common and divide it here, so we would get v sine 30 plus vb sine. Okay, wait a minute, here's a mistake, it is 60 degree. It was my mistake, it was 60. It was 60 degree. Okay, so va sine 60 plus vb sine 30 must be 0. You can solve it simultaneously to get va and vb. It was some example of two-dimensional motion. Here is another example to solve. Consider this. There are two persons. One's weight is supposed at 50 kg and the other person's weight is 70 kg. One's velocity is 8 meter per second. The other's velocity is 5 meter per second. Okay? They are rushing towards each other. They meet at point this. What would be their final momentum? What would be their final momentum? It is first question. The second question is the collision elastic elastic if they hug each other while moving, each other while moving. It means that at this point they just hug each other and start moving this in this direction. Okay, we can solve it vectorially. You can see that one momentum is in this direction, other momentum is in this direction. So the sum of these vectors, we can say that the sum of these two vectors, what would be the sum of these two vectors? According to our head to tail rule, this would be the sum of these two vectors. We are to find this vector. Okay, so we can say that the final momentum would be equal to under root of these two momentums. Okay, final momentum. Okay. Let me elaborate it as well. We can say that according to law of conservation of momentum, total pi would be total pf would be equal to total pf. What would be the total pi? m1 m1 v1 plus m2 v2, that is equal to m sorry that is equal to v, that v would be common between them, and m1 plus m2. But the thing is, these two vectors cannot be added directly because the velocities are perpendicular. To add perpendicular components, we use the formula under root m1 v1 square plus m2 v2 square. You know this formula. This is a Pythagoras theorem. Okay. What would be the sum of m1 and m2? 70 plus 60, 50. It would be 120. So calculating it, this would be 70 multiplied by 50 whole square plus 50 multiplied by 8 whole square under root. Please let me calculate it by my calculator. What is the answer of it? So by solving this equation, we are getting V is equal to 4.29 meters per second. We can calculate theta would be equal to tan inverse Py upon Px. Now, is this collision elastic? So we can calculate it by calculating the kinetic energies. Okay. So, what would be the kinetic energy initially? Kinetic energy initially would be equal to half m1 v1 square plus half m2 v2 square. Okay. So half, what is m1? It is 70. What is v1? It is 5. Okay. This is m1 square plus half 58 square. What would be the answer? 35 multiplied by 25 plus 25 multiplied by 40. Sorry, my mistake. It would be 64. It would be 64. It would be 64. My mistake. By calculating it, we can say that the total energy would be 35 times 25 plus 25 times 64. It is 247 joules. What would be the kinetic energy finally? Kinetic energy finally. We can say that v multiplied by v square, half v square multiplied by m1 plus m2. Okay, so half, what was the v? 4.29 square plus um, it would be plus, sorry, multiply by 50 plus 70. So the answer is 4.29 square multiply by 50 plus 6, 120 divided by 2. The answer is 1104. So the kinetic energies are not the same. The collision is inelastic. Hope you did get it. We will meet in another video. So bye.